Alright, we're going to knock out problems 20, 21, and 22 from the Geometry Chapter 3 self-test. So here's 20, where we're given a figure, and for 20 and 21 we're going to consider the triangle ABC that's graphed here. And number 20 says, give the coordinates of A prime, B prime, C prime when triangle A prime, B prime, C prime is the triangle ABC under a size transformation of a factor of 3. So what we're going to do is we're going to take our 3 points, A, B, and C. That's from our given triangle here. This is triangle ABC, negative 1, 2, 0, negative 1, and 2, 1. So I have the points here. When we perform a size transformation with a factor of 3, all we're going to do is take these 3 points and multiply them all by 3. So we're going to take each coordinate and multiply it by 3. So when we take point A and multiply each coordinate by 3, A becomes A prime, which is negative 3, 6. And negative 3 comes from negative 1 times 3 is negative 3. 2 times 3 is 6. B becomes 0, negative 3, because 0 times 3 is 0. Negative 1 times 3 is negative 3. And for point C, we get C prime, which is 6, 3, because 2 times 3 is 6. 1 times 3 is 3. So here are the coordinates of triangle A prime, B prime, C prime. We don't have to draw it or anything or graph it because it just says to give the coordinates, and we have done that right here. Number 21 is asking, in the situation of question 20, so back to those points that we had, which is true, and we're talking about angle measures here. And if we remember, when we do size transformations, one thing that always stays the same are the angle measures. If you take a shape and you make it bigger or smaller, the angle measures all stay the same. And this here, A is saying that the angle measures are the same. B is saying that this angle measure is 3 times less than this. We're taking 3 times this angle measure. Or that we're taking 3 times this angle measure, and that's equal to the angle measure of the image of A prime, B prime, C prime. That's not the case. The one we're looking for here is A, because this is saying that these two angles are indeed the same. BAC is the same as B prime, A prime, C prime, and they are, because if you make any shape larger or smaller, the size of the angles stay the same. And number 22, we're going to use the graph below, and they tell us that S is parallel to R, so we want to find the slope of S. We have no information as to what the slope of R is or what the slope of S is, except that we know that they're parallel, so therefore these two lines must have the same slope. Line R and line S will have the same slope. So if we knew what the slope of R was, we could just attribute that to S. We don't know the slope of R, so we just have to find the slope. And we're going to do that by just doing our rise over run, just picking a point. If I'm right here, and I can go up 1, 2, 3, and then I go left 1, 2. So I went up 3, left 2. And slope is rise over run, so the slope of line S is going to be negative 3 over 2. It's a negative slope because it goes down from left to right, so that's where the negative comes from. The 3 is our rise, because when we started here we went up 1, 2, 3, and the run is 2 because we went 1, 2. We went left 2. And again, it's a negative slope. B is telling us that T is perpendicular to R. So that means that line T and line R are perpendicular, therefore they form a 90-degree angle where they intersect. We want to find the slope of T. Well, we know the slope of R because the slope of R is negative 3 over 2, because that's the slope of S, and S and R are parallel. So that means that R and T have to have opposite reciprocal slopes. So we're going to take the opposite reciprocal of negative 3 over 2. And the opposite of a negative number is a positive number. The reciprocal of 3 over 2 is 2 over 3. So the slope of line T is going to be 2 over 3.